Good afternoon to all who have just joined us at Tech Innovation 2021. The last program for the day will be on the innovations in sustainable and intensive urban farming. Learn how they can help urbanized cities become resilient in their nutritional needs and overcome land scarcity and high overheads. Should you have any questions during the presentation, please type them in the Q&A feature on your screen. We will answer as many questions as we can during the panel discussion towards the end of this session. First up, we have Dr. Gil Shalev from Equinom, who will elaborate on how artificial intelligence can be used to breed strictly non-GMO source ingredients without gene manipulation or gene editing. Gil, over to you.
Thank you very much for the opportunity to speak here. I would like to share with you what we are doing in Equinom and also to present to you several solutions that we would like to bring towards the future food, or for us, the future ingredients. So before jumping to the details, just to give you an idea of what we are doing in Equinom. Equinom is an end-to-end plant-based ingredient company. And to become an end-to-end ingredient company, you must deal with, we must deal with four major pillars. One, you have to own the seeds, and you have to know how to breed those seeds, to move them and to push them towards the major source of ingredients. You have to own the genetic and the genomic informations to make the right combination. You must have the biochemistry information to understand how the relationship between the source of the ingredient is being attached to the food application. And definitely you need to understand how to make from those ingredients, from those sources, the real food. Only by understanding all of those pillars all together will enable you to become an end-to-end ingredient company using plant material as the major source. And all of my presentations as of today is going to provide you the evidence, and in Equinom decided to tackle this challenge. Goes without saying, the major part which basically enable Equinom to achieve its successful in several of those ingredients that we are developing is having the ability to have computational breeding technology and AI systems basically to elaborate and to make all of those decisions to create those ingredients. Before I jump to what we are doing, I would like first to discuss about the opportunities of today market, definitely speaking about the food industry. So, it's very clear to all of us that the growing industry, the growing food tech industry, by providing new sources of foods based on alternative proteins, is well defined. Everybody familiar with all the new technologies and solutions. But the ingredient industry, which is fairly, very, very conservative, and the ingredient industry is something that to move the ingredient industry will take you a fairly big time, is as of today do not developed and do not have the source to meet those challenges. And what we are trying to say over here, that the ingredient industry, no matter what will happen, have to evolve dramatically to make sure that it can support the growing industry. Going to the next level of what kind of ingredient we can source today, I think it's very, very understandable, and everybody familiar with that some of the ingredients are not sustainable. It's GMO in some cases. It's very expensive. For example, Impossible and Beyond Meat burgers are more expensive than the conventional meat industry. And this is also something which is also related to the cost of the ingredient. There is no diversity. We are speaking mainly on soy and pea today. And definitely the taste and the appealing is yet not there. I mean, there is a big movement towards of what we can say alternative meat, but it still doesn't give you the same feeling. And the last things which you may find surprisingly, but the conventional alternative protein based on plants, it's not sustainable. Eating Beyond Meat burger, for example, is not, from a carbon footprint, do not give you any value. You're not reducing the carbon footprint in compared to chicken. So yes, you don't kill animals. Yes, it makes more sense to start moving towards those directions, don't take me wrong, but it still do not really reduce the carbon footprint of what you can source from chickens. Yes, it's lower than beef, but this is not where we want to be. We want to start thinking about how we can really make these reductions significantly of what we are eating today. Before going to the solution, I want to just give you the frame of what we, Equinom, believe is going to happen in 10 years' time. So looking on the plant protein industry, you can see that plant alternative proteins, which is basically not meat and milk and other conventional proteins that we're familiar today, is going to be dramatically high, and it's going to grow. We are saying the projection is about $170 billion in the coming 10 years. Surprisingly, I think most people do not know that even today, the alternative dairies industries is fairly, very big. But the alternative meat is going to grow and basically going to become bigger than the ones that we have today in the dairy. Once we ask ourselves, well, what will be the sources? What will be the sources of the growing industry? So looking on the projections, mainly coming from the FAO, although there is an amazing technology developing, cell-based, culture-based, most of the source of the alternative protein industries that going to be in this world in the coming 15 years is going to be based on plant. Most of it. I'm not saying other technologies is not going to be evolved, but I'm saying the major source is going to be based on plant. And zooming in towards what will be the major source, I try to basically give you the cost of 1 metric ton of grains of each one of the major sources that you can find today. And it's easily being seen that soy and pea will be the driver force of the plant protein industry, following by faba bean. And after that, we believe that chickpea and munging and other crops will be the followers. But the major sources is going to be determined immediately by the cost of production. Cost of production is the cost of the grains, and those are going to be the major crops that are going to drive the entire plant protein industry to the future. So after I gave you some background information, I want to basically present you what is the solution Equinom is providing to the growing industry. So basically, as you already understood from the beginning, we believe that once you improve the source using nature, non-GMO, non-gene editing, there is no need, because nature already bred and have done those significant traits many years ago, but they are neglected to our current varieties, and basically creating new ingredients which are going to support the growing industry. And I will elaborate. So Equinom would like to make the crop more sustainable. We would like to make it more clean label and more accessible. There are several traits that we are working over here, which is a high resolution, but I would like first to just elaborate on the major bottleneck of where we already solved some of the problems, which is cost of processing, or the cost of the raw material, the cost of the protein. What exactly we have made in Equinom to reduce the cost in 2x, and sometimes even more than that. That will be the gate opener for the growing industry, because without it, there is no chance alternative protein is going to have the ability to replace conventional meat. And I will explain what do I mean about cost reduction. For doing that, I need to elaborate about what exactly the way the industry is today extracting protein. There are two ways to extract protein as of today. There is what we call it dry fractionation, and there is wet fractionation. The dry fractionation, it's very simple milling manufactures that basically grain and separate the starch from the protein, no need of water or any kind of chemicals. The problem that the protein level is very low and low in quality. So as of today, the industry that using dry fractionation, using it for pet food and feed. The isolated protein, which is the wet fractionation, this is the most common practice within the industry. The problem, it's using acids, water, and a lot of energy. That's the reason why carbon footprint in that perspective is not competing with other alternative, other sources, but it creates high quality protein, which you can use for food. Beyond Meat Burger is basically isolated pea protein. The cost is 2 to 3 times more expensive than concentrate. What we have made in Equinom, we took the conventional concentrated processing facility, the dry fractionation methodologies. We didn't change it, the same methodology. We changed only one part, the seed, the grain, the source of the grain. We bred varieties that enable the industry to create protein which go up to 70% without changing any kind of element within the processing procedure with dry fractionation. This is a game changer for the industry because doing that, it enables you to use the protein for food, and that's we believe, will drive the source of the entire industry, because at the end of the day, the saving cost of what we just made is going to create applications, food applications, which is going to be cheaper than the ones that you can source today. I mean, for us, it's not the conventional Beyond and Impossible burgers, it's the meat substitutes and the dairies food application. So to make the comparison of what we have made already, and by the way, those proteins is today is being extracted in North America in several of our partners, and the protein is going to be delivered small batches right now because we only have small batches to several of the multinational food manufacturers for evaluation. But I can tell you that we already evaluated internally, and we can guarantee that those results is going to be the driving force of tomorrow new food based on plant proteins. Making the comparison after we succeed to reduce the cost of reduction, I mean, there is a lot of values such as the ability to create a very lean in cost product. There is more room now for diversity. Carbon footprint is reducing more than 2x. And there is the ability of making local supply chain rather than huge conglomerates that producing the isolated protein. But the most important part, which we are trying to convey over here, that to create isolated protein facility, you need to invest $500 million. Therefore, if you look on the future projections, you will see that the industry of today is not going to meet the demand, because the demand have to be linked towards the investment of those huge manufacturers. And it's not there yet. What we are offering over here, because concentrated facility is very lean in investment, we are basically offering a solution to meet the future demand. Because building a concentrated protein facility, you don't need more than $5 million of investment, because it's a very simple milling manufacturers. To take what I just explained to you towards the real product that we are offering, we are already having a product pea varieties that is serving the pea isolated industry with a collaboration with Rocket. Rocket is the largest pea protein processor in the world. This breeding program was run for more than 5 years, 6 years basically, and then they are going to deliver the production next year. And we're already having several collaboration with multinational manufacturers, processor, and food manufacturers using our concentrated protein. We are the first company in the world that create concentrated protein crossing the 70%, which enable using this product to the food manufacturers. We are not doing it also. We are not doing it only on pea. We are doing it also on soy. We have good collaboration with Kanematsu. It's a huge trading house in Japan. sourcing soy varieties, specific soy varieties based on our breeding program. And in parallel, we're also working to create concentrated soy protein, the same as explained in the P. And that is going to serve several of the multinational manufacturers, food and processors. Same philosophy. We must reduce the cost of production, because without it, there is no way for us to overcome the demand. And we're also doing it in sesame. We have a collaboration with Sabra and several other companies. Yes, sesame can be a very amazing source also for protein, beside of oil and tahini. Now, speaking about the platform, which I have to elaborate a bit, is basically explaining what is the complexity to become an end-to-end ingredient company. And an end-to-end ingredient company have to deal with 4 different pillars. We have first to get the food application specification. We have to translate the food application specification to ingredient spec. After that, we are translating the ingredient spec to biochemistry profile. Then we are creating, based on the biochemistry profile using computational breeding technology, we are breeding a new sources, new grains to support it. After we are doing the breeding, we are producing the seeds and the grains. And finally, we are delivering the grains to create the ingredients to the food manufacturers. So without having the ability to close the loop from food to food, by running all of those pillars, there is almost impossible for you to become an end-to-end ingredient company. A few words about Equinom. Equinom founded almost 10 years ago. It's an Israeli company, which is a subsidiary. We also have a company in the US. So far in Equinom, we are about 40. There is more people, than it's over here. It's I have to update it all the time, but we are about 45 people globally. And most of our activities is based on plant protein. It goes without saying, partnerships, it's an essential asset for us. We are well covered with multinational food manufacturers, and we are trying basically to cover their requirements, and each one of them have its own needs. Sometimes it's cost, sometimes it's appealing, sometimes it's any kind of taste and flavors that we can solve using better sources, which is something unique. Most of the seed industry do not breed for food consumptions rather than consuming grains for feed. That's it. Thank you very much. I hope it was clear, and I'm looking forward to receive any questions that I will get from the audience.
Thank you, Gil. We will now hear from Vincent Wei of Archisen, who will present on urban farming solutions from his industry experience. Vincent?
Hi, good evening, everyone. My name is Vincent, and I'm the CEO of Archisen. I'd like to start sharing with you on why I started Archisen. I started my entrepreneurial journey with my co-founder, Suzan, back in 2011. I had already graduated for a few years with a degree in mechanical engineering from the National University of Singapore. And he graduated with a degree in biological sciences from NTU. We incorporated a company called Biomass, and we went about installing innovative IoT or Internet of Things systems in remote places such as teak plantations, cocoa plantations, and forests in Singapore, Indonesia, and Thailand. We got to understand problems faced in the agriculture and forestry industry, and got to work with agronomists from various scientific fields. We closed the company in 2015 due to cash flow and various business reasons. Infected with the entrepreneurial bug, Suzan and I started Archisen in 2016 with the objective of developing innovative ways to grow food for Singapore using controlled environment agriculture. The word Archisen refers to a combination of 2 words, architecture for sensor networks, as we believed controlled environment agriculture involved the use of an integrated system of sensors and automation systems. We noticed that Singapore was facing an issue with food resilience when we were importing 90% of our food. And so we were driven by the vision of providing everyone with the freshest, most nutritious, and flavorful produce. We started ourselves on a mission to establish the largest network of urban farms in Asia, and we believed we could do so by combining crop intelligence, engineering innovation, and market insights. We pride ourselves on bringing together the brightest minds to make the biggest impact on our food supply. So every consumer we surveyed wants affordable and tasty vegetables with 0 pesticides. But this is difficult because a large percentage of the fresh produce still contains residues on them even after they are being washed. So what we do at Archisen is to provide a holistic system for urban farming called CropDerm. In our innovative business model, we design and build the farm, as well as grow and distribute the produce. Our indoor cultivation system provides 100 times higher yield than traditional farming, and we use 90% less water than rural farming. We have over 50 crop recipes in our database, and our systems are powered by automation and analytics. The produce are also grown locally, are pesticide-free, and have numerous positive reviews by consumers and chefs. Our vegetables are sold under the Just Produce brand in all online grocery platforms, and we are also available in physical stores such as Little Farms and Howmart. This year, we launched Just Harvest, the first farm-to-table solution that provides a continuous supply of vegetables to hostels, restaurants, and cafes. With a combination of optimal growing methods, Just Produce crops pique your senses, such as the salty and juicy ice plant, the spicy mustard, the sour and tangy sorrel, and crunchy lettuce. These attributes have been carefully selected based on our numerous surveys, where we found that taste was really very important to the end consumer. We don't genetically modify the crops. Rather, we create the optimal growing environment that brings out the natural traits and flavors in them. The next product that we had developed was Just Harvest, a miniaturized growing system that's automated irrigation and environmental control and fits into any F&B establishment. Here is an explanation of how Just Harvest works. The plants are grown in the farm until they are ready for harvest. Then, the plants are delivered to the establishment in the form of towers using our proprietary transport method. In their establishment, staff can harvest the plants immediately to serve to customers. When Just Harvest is empty, the establishment calls us for an instant refill. The motivation behind this development was that many establishments want to have a farm, but often don't know how to farm or don't have a system that can provide enough vegetables for their needs. Next, I would like to show you a video of Just Harvest being successfully deployed in a grocer called The Village.
Welcome to The Village, which houses our Just Harvest system. Ready to find out how you can harvest fresh produce right from the store? The Just Harvest system grows fresh vegetables and herbs using hydroponics technology, just like a mini farm. To get your fresh greens, just approach one of the village's friendly staff for assistance. Your vegetables are priced by their weight. Afterwards, you can bring your Tupperware to make payment. It can't get any fresher than this. Just produce, just as it is, just for you.
If you would like to experience harvesting and buying produce from Just Harvest, drop by our pop-up store this Friday, Saturday and Sunday, 1st to 3rd October at Design Orchard Level 3, which is conveniently located opposite H&M. You can also support local by buying other local products at the store as well. For those who are wondering where our farm is, we currently operate a 7,000 square feet indoor farm in the west of Singapore with a production capacity of 100 tons of leafy vegetables per year. This is equivalent to 1% of Singapore's national yield. We use a vertical growing system that facilitates transplanting and harvesting, as well as monitoring systems which are automated. All the produce are harvested and dispatched on the same day to our customers. Some of the other products that are in the research pipeline are table grapes and stevia. These two products present huge market opportunities for the urban farming industry, and we will release more updates as we move along. I come to the end of my presentation. Thank you very much, and feel free to contact me if you have any questions.
Thank you very much, Vincent. Well presented. I would like to remind you to submit your questions on the challenge statements through the Q&A feature. Next, we have Dr. Suzan Shahrestani from Minnowtech, who will share how shrimp farmers have been given clarity and guidance to their harvest with pond-side biomass measurements to optimize the efficiency of their ponds. Suzan?
Yes, aloha. I'm currently in Baltimore right now. Very excited to talk to you about how we count shrimp with Sonar at Minnowtech. Next slide, please. All right, so I have some chickens up here because for the past 10,000 years, farmers have been counting their chickens pretty simply. They can see them. They can say, all right, 1 chicken, 2 chicken, 3 chicken. I got 3 chickens to feed and 3 chickens to harvest. Next slide, please. As you think about agriculture on land, 10,000 years later, technology, sensors, innovation have really come to take form. Cattle ranchers for example, are using drone systems and also AI to start to understand how their animals are feeding to move towards optimization. And I believe exactly what Vincent said, right? That sensors are the pathway. Technology on the farm is the pathway to optimize towards sustainability, traceability, and what I call the consumer conscious. Next slide, please. However, when you move to a shrimp farm, you don't have the luxury of seeing your animals. I'm a marine scientist by trade, and the joke is that we're like tree biologists, except our trees move and you can't see them. So in these murky waters, there are actually hundreds of thousands of shrimp being grown. And the farmer, much like you and I, cannot see what's actually underwater. Next slide, please. And the only way they do see what's underwater is when they begin to harvest. And then they're left with the daunting challenge of counting hundreds and thousands of smaller animals. So you can contrast this to a cattle rancher, small scale that likely has 200 to 300 cows, as opposed to a small scale shrimp farmer that's growing 100,000 to 200,000 animals at any given time. And depending on what region you're in, and depending on the level of intensification, that number is only said to go up. Next slide, please. And so here again, I just want to reiterate the challenges of shrimp farming. Shrimp are again grown by the hundreds of thousands in turbid water. Farmers are blinded to their count. Add in an aeration system as the one shown in the image, different types of objects in the water column, like standpipes, wires, a bunch of stuff that's in the way when you're trying to understand how many animals you have, makes it very challenging for the farmers to make decisions. Next slide, please. Minnowtech solution is fairly simple. The fact is we go into the pond, we put a sonar device, it's a sensor. I see it as a tool. We collect enough information and we provide the farmer with a count or biomass estimate of how many shrimp are actually in their pond. My background, I was using sonar devices to count jellyfish in turbid water. And so this was based on my PhD research, my doctorate research, moving from the open ocean as a fisheries scientist, counting animals of different species in the water column, using technology that was ahead of its time and trying then to develop computer vision and AI algorithms around the behavior of the shrimp. All of that condenses into this pond-side instrument that I hope farmers will put in the water and get a biomass estimate on the other side. Next slide, please. And really reiterating the point that it's a simple number at the end that the farmers do not have access to at this point. So if you think about you're throwing a party, you really want to know how many guests you have coming to your party. You don't want to order too much food and waste money on food, and you don't want to under order and have your guests leaving hungry. And so at the ground level, at the farm level, when farmers are up to 50 to 60% inaccurate with how many shrimp they actually have in their pond, they're unable to optimize feed. And so when we tell them, you know, you guys have 7,000 tons of pounds of shrimp in your pond, this is how much you should feed. As you can see on the right, this is a feed bag, the back of a feed bag or a feed car for shrimp farmers. It tells them how much to feed based on how many animals they have in the pond. But if they don't know how many animals they have in the pond, this card is seemingly useless to them because they're over and under feeding. So Minnowtech's true value proposition is not necessarily this fancy sonar hardware that's going in the water and scanning the pond. It is doing that, but it's the number. It's the number that allows farmers to make daily decisions on the farm, which can reduce their feed costs up to 65%. Shrimp farmers are operating on tight margins, and so this is really an important thing for them. Furthermore, if they're underfeeding, that means that they're not maximizing the growth, maximizing the efficiency on the farm, and so they're losing out on capturing a higher market price. And what's really remarkable is, as you start to monitor daily, you have an understanding of how your crop or your shrimp are growing from day to day. And also, if there happens to be a mortality event from day to day, it can be flagged. So yesterday I had 100,000 shrimp. You start scratching your head. Today I only have 50,000. That becomes a flag for me. I should check what's going on in my pond. And then finally, harvest. So farmers are trying to predict when to harvest to capture that higher market value, when to harvest based on how their processors can manage the incoming amount of shrimp. And so all of this together comes from the foundation of just knowing how many shrimp are in your pond, again, which is a really big problem in the industry today. Next slide, please. All right, so this is how farmers are currently measuring their biomass on farms. They are taking a feed net, dropping the net into the water, a feed tray rather, with some food on it. Shrimp jump into the net, and then they slowly pull it up to get a sample on how many shrimp are in the pond. When I first started looking at shrimp biomass from, the nerdy PhD sampling perspective, I said, oh wow, if I could just go in and tell them how to sample better, I think that they would have a more efficient biomass number. So that's what Minnowtech is about. We are about sampling. We want to sample biomass with a high accuracy. We want to remove the user error, the bias that's introduced from inaccurate and improper sampling methods, effectively by automating the process, teaching Sonar and a computer how to count shrimp. Next slide, please. And so the shrimp farming industry is growing. There's high growth for not only ponds at a spatial scale, right, as they start to take up more and more space, but also intensification. So you can imagine as you start putting more animals in the water, you're going to need to have a better understanding of how many animals are in there because the risk is higher. The risk is higher for not optimizing your feed. The risk is higher to the environment. The more energy you put into the water that's not being consumed by the animals, the more energy that's there for other stuff to consume, disease, and that's a big problem. And so, next slide, please. I really believe that you can't manage what you can't measure. And as we talk about intensification, pond side. As we talk about intensification on land, it's about pushing the limits of what we can grow. And I truly believe that without technology, without sensors, like Vincent said, there is no way to manage the intensification process. Now, that process is happening with or without us as we become space limited. And so it is our job, the innovators, the panelists on this call, to really introduce the farmers to technology that allows them to optimize for sustainability, for the environment, as well as for a sustainable food source for the growing population, as we all know. And then also it's about consumer consciousness, being aware of what you're eating, and that, hey, this is coming from a place that's environmentally sustainable. I think it's tremendous that we lay down that pathway with technology before we get to a point where it's going to start to, intensification starts to do more harm than good. Next slide, please. Yeah, that's it. Thank you.
Thank you very much, Sue. And now we have Desmond Chow of Singapore Crawfish, who will present the latest innovative technologies in his field of work. Desmond, over to you.
All right. Hi, guys. Thanks for having me. I'm Desmond Chow, founder and CEO of Singapore Crawfish. It's a great pleasure to be here today. So Singapore Crawfish is an aquaculture tech company specializing in growing crawfish, producing the gold standard in the world. So although we are a local company, we have a mission and a dream to feed the world. So why crawfish? A lot of people often ask me, right? We strongly believe that crawfish can help alleviate world food poverty because of a few reasons. Number one, they are very, very hardy and easy to rear because they used to come from swamps. Imagine when they originated from swamps living in those conditions. Right now, if we put them in a cleaner condition, environment, how well will they grow? They are also fairly easy to rear, that it doesn't require a huge startup cost or huge capital to grow it. And that's why we believe farmers all around the world, they are able to grow crawfish. Another important reason is that crawfishes, they grow very, very fast. They only take 4 months to reach marketable size. Compared to other produce that such as fish, certain marine fishes, lobsters, they might take 1.5 years or some even 2 years, 3 years to reach marketable size. Crawfish, in just a short 4 months, you can have a highly nutritious meal, right? Crawfishes, they are very, very high in protein, high in amino acids, and high in vitamins. The best thing of all, they reproduce at an exponential rate. Per female crawfish, we can today grow up to 1,500 babies per brood. So let's talk about crawfish. The global demand for crawfishes are at its all-time high, all around the world, starting from America, going to China, Europe, Asia, everyone is talking about crawfish. The crawfish demand today is extremely high, and the industry value is at $9.5 billion US. You see, US has been eating crawfishes for decades or even centuries. I'm sure you guys have heard of Louisiana crawfish. And in China today, in 2019, China produced 1.8 billion kilos of crawfish, but it's still not enough, simply because the demand way outstrips the supply. And in Europe, the demand for crawfish is also very high. Let's take a look at a country like Sweden in Scandinavia. 8th of August is their annual crawfish day, annual crawfish party. And in this part of Asia, the demand for crawfishes is rising really, really fast. The global crawfish market is expected to grow at 17% per year. But there's a problem. The problem is there's a huge shortage of fries. So in Singapore Crawfish, we are actually growing this special breed of crawfish called the Chirex quadricarinaceus. Most people, they might be familiar with its cousin called the Procumbers clarki, which is what the US and what China is growing right now. But as you can see from this slide, right? Given the same time period, so the same time period of 4 months growth, you can see that the Chirex way outgrows the cucumbers, which means that it has you can yield 60% more meat than the cucumbers. And that also means that there's a huge replacement market, especially in China. Right? So as I mentioned earlier, there were 3 main industry problems. Number 1, the lack of crawfish. Number 2, the lack of sustainable commercial crawfish hatchery. And number 3, one of the major problems is that traditional farming is laborious and it simply doesn't work. Let me explain further. You see, so in the past, where you have traditional techniques, even right now today in most developing countries, they are practicing these techniques where they just simply throw their crawfish fries or crawfish into a big pond, right? So before they harvest, they just pray. They pray really hard. Please let me harvest something, all right? So that used to work in the past because technologies was not that advanced, right? People used to harvest 50% and 50% was left in the ponds or in the lakes to reproduce. But because of improvements of technologies today, farmers started harvesting 90%, only leaving 10% to reproduce. So that is totally not sustainable, which is why governments today, they have imposed bans, on overfishing, on overharvesting, right? And then we move slightly forward to modern techniques, which is practiced by developed countries such as the US, Israel, and Australia. What they have here is called the egg stripping technique, where the scientist or the researcher or the farmer will actually take a fine-tooth comb and comb out the eggs from the underbelly of the crawfish. They will then put these eggs in an incubation chamber and hatch them. However, it has also its pros and cons. One of the major problems of this technique is that it is extremely laborious. Right? Especially, you can do this with 10 crawfishes, 100 crawfishes, or maybe 1,000 crawfishes. But when you have 100,000 crawfishes, how many labor or how many people are you going to get to do it? The worst of all, every time you manhandle a pregnant mother, you are stressing the mother, you are exposing both mothers and eggs to disease and bacteria. So at Singapore Crawfish, we have patented a special hatchery technology, which I'm going to show you guys in a bit. Firstly, let's show you a bit of comparison from the traditional hatchery. That's totally no benefits at all. With the modern hatchery, which is the egg combing method, you can have increased production and year-round production. But at Singapore Crawfish, with our hatchery, we can have high survivability, increased production, year-round production, utility and space efficiency, reduced stress, infection risk-free, and labor efficiency. So mainly, just to give you some context, right? We have filed for patents for our technology and our hatcheries. To give you some context, we can have reduced manpower. So example, in the traditional hatchery, where you need 100 people to produce X amount of crawfish, today at Singapore Crawfish, all you need is just 1 person and you can produce the same amount. With our automated hatchery system, there's an increase in survivability. And with our system, it is highly modular and it can be placed at anywhere on Earth, right? Lastly, we have our cloud AI monitoring system, where we are able to just sit at the comfort of our office or our homes, and we tap on our AI system, we can know exactly what is happening in each particular tank. Be it there's a rise in pH, temperature, we will know and we will track, and it's all in our cloud system, right? So this is the first pillar of our company, which is Aquatech. The second pillar of our company is actually genome research. Right, genome research is very important, right? Because a lot of people actually ask me, Desmond, what's your defensibility of your company, right? Aquatech technologies. Technologies might be copied. And I answered them, yes, that's true, right? Today, if the US comes up with the iPhone 13, you bring it to China, maybe 1 week later, they might have the same thing, right? So what is the defensibility to our business is our genome research. In Singapore Crawfish, we have a genome mapping program where we actually map out the different genes of our crawfish and we keep our genetic broodstock and we make them more disease resistant, lower mortality, environment tolerant. They have higher growth rates, higher fecundity levels, and higher meat yield. So as you can see from our results with our technology and genome research, we can actually achieve 250% more fries compared to our competitors. And with our feed technology, which is our third pillar, all right, over the past 5 years, we have studied over more than 200 ingredients. And today, by mixing 12 special ingredients, we can actually get a significant yield from our crawfishes. As you can see at the bottom of the screen, in month 6, with just normal feed, they can yield about 60 to 69 grams. But with our in-house feed genetics and technologies, we can yield almost double the weight, right? So let me emphasize on this again, our 3 main pillars of the company, our high-tech hatchery, our genetic mapping program, and our proprietary crawfish feed, right? It's not only that, there's something interesting about crawfish, right? As all of you know, crawfish are crustaceans, similar to lobsters and crabs, where you only eat the meat. And a lot of you must be wondering, what can we do with the shells? Do we really just throw them away? You see, crawfish shells, go or bio waste. We have found out, and we are conducting research right now, that our crawfish shells might be used to convert them into biodegradable plastics, cosmetics, animal feed, or even fertilizers. And if we move up a tier, chitin and chitosan can actually be extracted from our crawfish shells, and they can be made into human-grade supplements, anti-inflammatory agents, and it has a wide range of biomedical applications and use, such as tissue engineering, drug gene delivery, wound healing, and even stem cell technology. So it's a circular economy. We don't put anything to waste, right? Although the crawfish, we enjoy the tasty meat and we don't waste the shell. So we have our expansion plans. We started in 2018 in Singapore. In 2019, we expanded to Malaysia, 2020 to Indonesia, and this year, 2021, despite COVID, we have expanded to Cambodia and Brunei. And these are our expansion plans, and we plan to IPO in the near future, right? So I believe a picture speaks 1,000 words. So just gonna show you a bit more of our crawfishes. Look at the immense size of them, the number of eggs on them, and the number of fries we produce at our facility on a monthly basis. Yep. So just to end off the presentation, I know there are international viewers here today. So with crawfish, we are also implementing a multi-cropping system, right? Instead of just yielding one crop per area, right? With our crawfish, fish, and vegetables, we can yield 3 crops at the same time. So this is not just a concept, right? We have actually done this, and you can see a farmer that just grows paddy on 1 hectare of land can stand to yield a market value of $7,500. But if we add paddy, crawfish, and fish, we can yield about $30,000. And this is something very, very amazing. And this can help improve the lives and improve the income of the farmers. Most of all, we have done this, and we have done this in Malaysia, in Indonesia, and we are very happy to share what we have, our knowledge and our technologies, with governments, with businesses, and with farmers all over the world, and help feed the world. Thank you.
Thank you very much, Desmond, for that very, very interesting presentation. Before we move on to the panel discussion, if you have any questions, please submit them via the Q&A feature at the left panel on your screen. Anton Wibowo, CEO of Trendlines Agrifood Innovation Center, will be the moderator for this panel discussion. We will now invite our panelists on screen back as well. We have Dr. Gill, Dr. Suzan, and of course, we have Desmond. and Vincent as well. So over to you, Anton.
Thank you very much, Alvin, and good day, everyone. Thank you, panelists, for your presentations. I think it is very interesting to show the diverse approaches, right, to try to solve the challenges that we see in the food system, in trying to intensify the systems or the production systems. And we get a lot of questions from the audience. I will try to categorize or group similar questions so that we can address all of them. And first question to Gil is regard with your the pea protein. Okay, so there are two questions here. First, how different is your breed as compared to conventional peas that also do not require acid or base extraction? And the other question is, have you measured the difference in the protein digestibility as compared to what they are in the market?
Okay, so for the first question, as of today, the commercial yellow pea varieties within the field can get up to 22% in protein, and therefore the air classification way to process cannot reach a high level of proteins because of lack of protein, and there are more traits in related to that, and that's also that's the major reason why the conventional yellow pea varieties as of today cannot using dry fractionation concentrated technologies for food. In the case of Equinom, because we succeed to increase the protein level within the bean and also working on several biochemical components which enable to efficient the dry fractionation, the air classification methodologies, that enable us to increase the protein level and therefore using it for food. For the second question, which you asked, digestibility. Yes, so no, we didn't check the digestibility, which is it's a challenge. I agree that it's very important traits to validate, but we did increase the amino acid composition, which is one part of what we call PDCAS, which is defining the quality of the protein. And we're all familiar that P is lower in the PDCAS ratio, but the way to improve it is increasing digestibility, which is more challenging, but also increasing the protein, sorry, the amino acid composition, which is something that we have the ability to improve, and we already have done some steps towards those directions.
Okay, thank you, Gil. So if I can summarize that part, so what Equinom has delivered is increasing the absolute number of the protein, okay, and then increasing the amino acid profile, but on the point of digestibility, that is still to be figured out, or to be tested.
Yes.
Okay.
Yes, definitely.
Thank you. And we have questions also for Vincent.
Hi, Anton.
Hi. With regard to your the 7,000 square meter facility.
Square foot, yeah.
The square foot, sorry. The question is, how is that optimized? How is the operation optimized if you compare it with regard to the energy utilization as well as the other inputs like the manpower, so that the yield is the maximum and yet at a cost that that is acceptable to the market?
Yeah, thanks for that question. I think maybe I can just address a question relating to the energy consumption. It is an important question that is often asked relating to indoor farming. For many indoor farms, the main sources of energy consumption come from grow lighting and the need for climate control and ventilation. These factors are particularly important for plant growth and yield optimization. And to provide some context to the question that you mentioned earlier, one of the key parameters which is important is that the farming model has to be profitable. After you factor in all forms of operational costs that you mentioned, manpower, energy, land, consumables, and so forth, including energy costs. So firstly, it has to be profitable. Secondly, we work on various initiatives to see how we can reduce the various inputs of the operational costs. So for energy consumption, for example, we look at more energy efficient grow lighting by optimizing the spectrum, as well as the electrical energy to rural energy conversion. We also explore various cost-effective mechanical methods to reduce the ventilation and climate control costs so that the requirements of the environment are not so intense while maintaining similar yields. We also look at various automation solutions out there to reduce labor costs and to increase productivity. And ultimately, it is also important to understand what the market needs and to ensure that the operational planning or the farm production is planned according to the needs of the buyers. Yeah.
Yeah, thank you, Vincent. I think to add on that, as a follow-on question, besides the topic on energy or the challenge on energy utilization, what are the key issues that you think are still for urban or indoor farming that is still not addressed yet, and something that we hope to see coming out from other innovators or researchers?
Yeah, thanks, Anton, for that question. I think energy use efficiency, reduction in labor costs, increasing of crop yields are all very important parameters. What is also very important is to make sure that what you produce matches the needs of the market. So for example, when we were trying to produce vegetables, right? There are so many different vegetables at different prices. So what to produce, we had to study the market, talk to customers, talk to chefs, talk to restaurants to understand what fits their palate and what is the best way to produce it to fit their logistics requirements. And I would say that for different cities and different countries, the needs of those countries will be different, and how to fit into the food supply will be different as well. And each country will have their own challenges relating to their existing producers, as well as existing buyers, and how to make sure that you fit into the overall food value chain. And if there are innovative systems to help facilitate these processes, aside from technology, that would enable technology implementation to be more seamless when the different farms scale up.
Yeah, thank you, Vincent. I think that's a very interesting point, that when we talk about innovation, especially for the food sector or the agricultural sector, it's not just about innovation in technology per se, but we need, I think, to innovate on the business model or on the supply chain model to the business. Yeah, thanks for that reminder. And the next question goes to Suzan. This is with regard to the accuracy and the limitation of your technology. At what level is the accuracy of measuring that for shrimp?
Sure. I always say that my job is easier the more animals they are and the larger the animals are. And so really, when you're talking about accuracy limitation, it has everything to do with a size threshold. So currently we're measuring 10+ gram shrimps at an accuracy of 95%. We are working to lower the threshold. So we want to work with smaller and smaller shrimp, get the entire grow out curve or accuracy across the grow out curve. So while we are able to detect and count smaller, below 10 gram, below 5 gram shrimp, that accuracy doesn't hit the 95% standard that we're going for. So we're continuously working towards that. But right now, 10+ gram, 95%. And that's a little bit conservative, you know.
Okay. Thank you, Suzan. And is there any plan to also expand this application of the technology to other species that is also, living in a system that is murky or muddy water?
You know, crawfish. No, but I could help. But I think that you're asking if I'm moving away from crustaceans, and the answer is yes. You know, we have our sight on finfish, and so even if the water isn't murky, there are things we can do in the salmon industry. There are things that we're looking to do with tilapia, as well as catfish in the U.S. So animals that are grown in ponds or even offshore cages. I think the major challenge right now when you're trying to count animals, as an example, in an offshore aquaculture cage for salmon, is that you're really limited by the amount of the computational demand required to get information on fish that are consistently or animals that are constantly moving. And so what I like to pride us on is that we are not necessarily going for the sexiest technology out there. We're really trying to be elegant about how we track and manage different animals. And so what we do in shrimp, our hardware will likely not have much modification, but it's a modification to our understanding of the behavior of animals. And so fish are really great. They're larger. They have a beautiful cadence to the way they swim. You know, shrimp, crawfish can be likely seemingly chaotic in the water column, scuttling around all over the place. But yeah, our secret sauce is that we pay attention to the behavior of the animal and how they're utilizing their space. So with that in mind, we're eager to step into all and many species and think that we started with the hardest one. So hopefully it should be a bit easier from here on out.
Thank you, Suzan. And Desmond, seems like you have found another possible innovation that you can apply to your system.
Definitely.
And the question to you is more about, I think this where we want to talk about the sustainability of the approach or the system, right? There's a question from the audience about how you combine the growing of crawfish to with the paddy growers. Can you elaborate more on that and how that works? We saw the financial benefit to the farmer, but if you look at the sustainability from the environment, how is that more helpful? Or yeah.
Sure. Thanks, Anton, for the question. So basically, right now in the industry, like as I mentioned earlier, the ways of reproductions are very, very primitive. So farmers usually they own big plots of land, right? And for us as a business, I always advocate we need to know our strengths and our weaknesses, right? So example, in Singapore, what are our strengths, right? Our strengths are our technologies and our knowledge. But however, what are our weaknesses? Our weaknesses is we are land constrained and labor cost is very high. So when we go overseas, that is actually kind of opposite, right? They have vast pieces of land. They have a much bigger population where we can utilize this land to grow crawfishes, right? Just to give you another, just to give some context, right? On an A4 size piece of paper, I can put 1,000 little fries on that one A4 size piece of paper. But when they grow to adulthood, maximum, I can only put 2 adults on that piece of paper. So to answer your question, what we would want to do is that we would want to work with cooperatives, governments, or even businesses, right, to build these hatcheries, right? These hatcheries might be a little bit more capex intensive. So once we build up the hatcheries, it is very modular, and we are expected to produce a minimum of 100,000 fries every single day, right? So with these fries, we will actually be able to distribute them to the farmers, and these farmers can grow them out in their paddy fields. At the end of the day, we will even offer them a buyback contract. So these farmers, they don't have to worry, who to sell it to, where to sell it to after I've grown the crawfish. So it's a whole cycle where the hatcheries, on-site hatcheries, produce fries, distribute them to the farmers grow the fries, supplies it to the market. Yeah, everybody's happy.
Thank you.
Thank you.
Well, there's the final goal, right? Everybody has to be happy,
yes,
including
yes.
the planet that we are living in. Thank you, Desmond. And now I go back to Gil. I think you mentioned briefly in your presentation about your computational breeding capability within Equinom. So could you explain how does that work with the with the industry? Do you develop seeds according to the needs of the farmers, and then you supply them the seeds, and that is that applicable to other varieties as well, besides the examples that you've shown in the presentation?
The computational breeding technology that we developed, first, its major principles is basically looking back 100, 200 years ago on the genetics that was grown in the globes in different regions of the world, where the quality and traits that were basically abandoned over 100 to 100 years of breeding is there. And the reason why we don't find the quality of the current food that we are eating is because the breeding industry were pushing very strongly and very aggressively towards yield performance, because it's a cost-driven industry, and the cow doesn't really care about taste and functionality and flavors. It's only about the cost. Now, what basically the computational breeding that we developed bringing is basically accelerating the process of taking a very old variety which doesn't have all the agronomy performance but do have the qualities. We are recognizing genomic regions of interest using gene discovery, and with a very accurate processing, we are creating classical crossing. It's a classical crossing. We don't do any gene manipulation with GMO, and we call it in a way kind of we uploading the old genes towards elite germplasm. This is basically how we are doing it. Now, to elaborate on the process, you can imagine yourself, and this is what makes Equinom very unique in the seed industry, is that we are taking the farmer as a very crucial producer, but we are not breeding for the farmer. Because the farmer is not the ones appreciate the quality, the protein, functionality. This is not part of his life. This is the life of the food manufacturers. So the uniqueness of what we are trying to convey over here is that only when you are crossing the farm gate towards the ingredient manufacturers and the CPGs, that's the only way to basically breed grains for food. Because the value that we are creating in those grains is not being appreciated by the farmers because he's not eating it. And that's basically what we are doing, part of our business model. We are taking the farmer very seriously because those guys have to produce the grains. It has to be economically viable for them. They will get even a premium by growing our production. But the value capture of what we are creating is not going to be in the farm gate. It's going to be within the CPGs and the ingredient manufacturers, because they will appreciate what we are creating in those grains.
Thank you, Gil. And so is that also theoretically applicable then to, let's say, indoor farming or varieties of even we talk about fruits, fruitings or grains, other types of grains? And what is the plan for Equinom to develop other varieties?
So yes, definitely. It's a generic system because we're speaking about DNA, and DNA is generic, and breeding is basically very generic kind of a process. gene discovery is generic. So therefore, the system can be applicable to any kind of crop. In Equinom portfolio, our aim is to start commercializing. As of today, we have pea and soy. The second tier crop, we are working on other legumes because we believe legumes family will be the major contribution for plant protein. So such as chickpea, faba bean, mung bean, and cowpea. And then the goal in 3 to 5 years is to expand to other crops, which is maybe barley and oat. And now taking the technology towards other crop, if you ask me, I think it's essential because the only way to improve the food that we are eating today is dealing with the source. After processing and the kind of attributes that we have to create, but the source is the major key component to improve the foods that we are eating. But the only way to do it is that the breeder will speak food. If the breeder will speak farm, crop protection, and yield, we are going to maintain our current quality of product, which is big volumes, big trucks of grains delivering to the cows and to the feedlot, which is nice, which is good, but that's not what we call in Equinom food.
Thank you, Gil. You brought up an important point is what value actually the technology is delivering and who are the eventual users that are benefiting from that, right?
Exactly.
And Vincent, I remember you said that some of the vegetables that you grow is after intensive survey and knowing what the market wants. And the next question is actually there's quite a fair bit of interest on your just harvest model in Orchard, and is there any plan to develop even or downsizing that system into something that can be used at home or to the consumers?
Yeah, thanks, Anton, for that question. Sorry, just to respond a little bit, since you were talking about genetic editing or producing new cultivars. Currently, we don't produce any products that are genetically modified. But just to add some flavor to this, it is important to continuously develop new varieties and to focus on the food and to focus on the quality of the produce with the main objective to provide something that is more nutritious and something that is more higher value to the customer. So from that scientific perspective, I think that's very important. Coming back to Anton's question on just harvest, currently our systems are more catered towards retail or the businesses rather than the consumers. So our just harvest systems are catered towards grocers, to supermarkets, to restaurants, to small F&B outlets, with the main objective for them to supply it as a produce or allow it to be purchased or have it as a dish for the end customer. For someone who's living in a residence, whether it's in an apartment or a house, that would be something that would be further down the line. We don't have a system for that at this point in time. However, if you are living in a residence, I would highly encourage you to grow your own food. There are so many other ways to do it out there. You can use a box, you can use hydroponic systems, and there are already several suppliers out there selling systems to grow stuff at home. And so I would highly encourage people to grow their own food. When you grow your own food, you understand the value of not using pesticides, and you understand the difficulty around growing food in general. So I would highly encourage everyone to grow their own food at home. Yeah.
Thank you, Vincent. And I see parallel between Archisen and Equinom in that you're taking the non-GMO, non-gene editing approach, and well, who knows, one day eventually it will be Equinom developing the seeds for the new variety of vegetables that you will be growing. So I hope to see that kind of partnership happening. And to Suzan again, we see that, okay, we see the value of the results that your technology will deliver, right? And that can then lead to intensification of the production with higher density of streams. How do you encourage? I mean, we know the profile of farmers or stream farmers, especially in this region. Most of them are maybe medium to small size, or we call them the smallholder farmers. And I think tech adoption is a challenge, even though they see that there's value in the technology. How do you go about that challenge?
Yeah, I think it goes back to what I was talking to earlier about, as we develop technology for the farm, it shouldn't have this kind of sex appeal to it. It shouldn't have, fancy bells and whistles and things that prevent a barrier to the farmer to engage with a seemingly complicated device. We are trying to make the hardware robust, something that the farmer sees on the farm, and then providing them with a number, again, like a temperature sensor or a pH sensor or a DO sensor that's just popping up on their screen. And so my challenge is exactly what you described. How do we have the farmer integrate this decision-making tool into their daily operations? And what does that mean for them? That's our learning curve. We're engaging in that right now. How do we roll this product out? What do our customers, the farmers, want to see? I really don't want them to have to access multiple technology platforms to get the data that they need all in one system. And so we're really developing not to be, this platform for biomass, but instead a tool that plugs into a system that farmers are already comfortable with. And so you do see technology platforms around aquaculture. I'll name drop AquaConnect out of India, Jala out of Indonesia. These are companies that are trying to introduce technology to the farmer. And so our game plan is not to reinvent that wheel, but just to plug in and become another device on the pond that is giving a biomass number. And to me, if it's the farmer then looking at the number and writing it in a notebook, as long as that number is more accurate than what they had before, that's the change that I'm looking for before I'm trying to just overtake a farm with tech and wireless sensors. That's not in the game plan. This is about introducing something farmers are comfortable with, that they see on the farm, that they can envision on the farm and envision in their daily operation. So we're very careful about how we introduce ourselves.
Yeah, thank you, Suzan. I think that's really important, because I strongly believe that any technology, for it to make an impact, no matter whether it's a super deep technology or or what we classify as not so complex technology, but at the end of the day, it's about adoption, right? And then it can deliver the values to the users.
Cool.
Thank you, Suzan. And question to Desmond. Okay, I think you have found a few interested farmers among the audience. So they're asking questions like, first, what is the FCR as compared to, let's say, stream? Why would farmers choose to grow crawfish instead of stream?
Okay, so number one, crawfishes, they are more disease resistant, temperature and environmental tolerant compared to shrimps. There are many known stream diseases that can affect and wipe out streams, as example, the white spot disease, right? But for crawfishes, they are more tolerant and disease resistant. Number two, the pricing of crawfish, it's at a premium. So it's slightly higher than shrimp. Right now, the pricing of crawfish is below lobsters, almost on par with crabs, and above shrimps. The third thing that you asked me about the FCR, that's something very, very amazing. Crawfishes have one of the lowest FCRs in the world, and right now we can achieve roughly about FCR 1 to 1.1. Although there have been research papers on the internet that states that certain institutes they actually say that crawfish, the FCR for crawfish is 0.9. So that's also very, very amazing. Yeah. So again, it depends where do you grow your crawfish, right? Example, if you grow them in the paddy fields or in the ponds, in the natural environment where they have natural food source, the microorganisms in the soil, so the FCR goes even way lower. Yeah.
Interesting. So theoretically, if all of us are converting into crawfish, we can actually have a really circular food system in the whole world, right?
Exactly.
Okay, that's an interesting thought. We have a little time left, so I will just give each one of you 30 seconds to what is your closing remark or your message to the audience. Maybe we can start with Gil.
I think, our message is that we believe plant breeding can make a disruptive role within the food industry. It's just a matter of putting the right puzzle in the right frame.
Thank you. And Vincent?
Yeah, whoever you are in whichever country or city, I would encourage you to buy local, buy from your local farm, try to grow your own food, and try to get your hands dirty, even if you have tried a few times and it doesn't work. So keep on trying.
Thank you. And of course, visit the Just Harvest.
It's an orchard this Friday, Saturday, and Sunday. Just pop by and see some. Get your hands on some local stuff and harvest it fresh, and you can buy it on the spot.
Thank you. And Suzan?
Sure. More seafood. I think that speaks to Desmond too, right? The FCRs, the sustainability, the traceability, and utilizing less land and moving to water for 3D vertical space. All arrows point to aquaculture for food sustainability. So yeah, eat more seafood.
Aquaculture for the win. Okay.
Yep.
Desmond? I think Desmond will agree to that.
Totally. So I think at Singapore Crawfish, with our three main pillars of our technologies, our aquatech, our genetics, and our feed, we aim to produce the world's gold standard for crawfish. And although we are a local company in Singapore, but we aim and we aspire to feed, the populations of the world through crawfish. So again, I would like to say that we are very, very open to share our knowledge, our technologies with companies, governments, and farmers all over the world.
Thank you. And of course, thank you IPI for having organized this and having us in the panel. And thank you panelists for your time. And I will pass the time back to Alvin. Thank you.
Thank you very much, panelists, for that very interesting and engaging session. We've now come to the end of Day 2 of Tech Innovation 2021. I hope everyone enjoyed today's sessions. Here are some administrative notes. Please click on the info button on your screen to submit a rating out of 5 stars before exiting this session. We look forward to receiving your feedback. All webinars from today will be available on demand via this virtual portal until the 1st of October 2021, so you can catch up on the sessions that you may have missed. The webinar live stream will open at 8:45 a.m. tomorrow, Singapore time. For Day 3 of Tech Innovation, we will feature exciting keynote and thematic sessions on how health and wellness can be reimagined with innovative solutions such as non-invasive healthcare diagnostics and evidence-based traditional herbal medicine. Check out our key partners on-demand technology showcases by selecting 22nd September under the agenda drop-down list. You can also chat, secure a virtual one-to-one meeting, or request for a call back with exhibitors by clicking the Connect button in their profiles. If you're interested to speak to IPI tech experts, simply search for their names via the Attendees button. Thank you once again for participating in Day 2 of Tech Innovation 2021, and we look forward to welcoming you back tomorrow. Thank you.